Okay, good morning, or it won't be morning when you hear this video. But unfortunately, our nanny had a fever yesterday, so I'll be spending the day with my daughter while our nanny gets COVID tested. So I know that you guys will have some or need some help with the pig's flies. So this video is intended to help you guys set things up so that you don't feel super lost. And what I'm going to do is I'm going to pause at certain intervals in this video, and that will give you guys a moment to pause and maybe see if you can do the rest of the problem yourself. So I have the pendulum right here, and the first thing you should notice is that without a timer, this is going to be really hard to do, right? But I mean, the whole reason that we're doing this, right, is because it's within Unit 3, which had everything to do with forces. So hopefully it should make sense that, we should draw out some forces. So here is our conical pendulum, our pig, and I'm going to go ahead and label some forces. So acting on our pig is going to be a gravitational force that's pointed down, and then you're going to have a tension force that's pointed up at an angle. Okay? We're going to want to sum the forces, so let's go ahead and do that for the y direction. So our first equation will be the net force in the y direction. And you need to ask yourself, is our pig accelerating? Well, it's not like our pig is moving up and down in a wave-like pattern when it's moving around in a circle. So I hope that makes sense to you that it would be a balanced force in this instance. Okay, now what are the forces? If it's balanced, something has to counteract it. And so I'm going to go ahead and use a different color. Let me switch over to pink. And this force is going to be the y component of tension. So this is going to be Fty. Okay? And so if I was to continue my net force equation, I would say that the net force in the y direction is going to equal to the tension force and then minus the gravitational force. Once you have those two relationships, well then we know, since it's equal to 0, that the tension force has to be equal to the gravitational force. And that's that. That will be our forces that are acting in the y direction. So I'm going to go ahead and pause, and if you think you know what to do at this point, you should pause this video and you should try it. Okay, now if you still need a little extra help, let me go ahead and get you set up for the x direction. So you'll want to get the net force in the x direction. Now, there's no way that this pig is going to stay in a circular path if it wasn't accelerating, right? So what we need to do is we need to identify what is our centripetal force, right? So I think it's important to point out that this net force in the x direction has to be accelerating. So it's going to equal to m times a centripetal, because it has to be staying in a circular path. And then what is that force? So let's go ahead and draw another line. Okay, well, if it's not super obvious, if you go back, since our tension force is at an angle, let me pick a different color. This force that's keeping it in a circle is going to be the x component of tension right there. And so coming back over here, this force is going to equal to ftx, right? So we're going to have an equation that m times ac is going to equal to ftx. Okay? And so there is our second system of equations. Now, I think it's important to note right here that there is some angle theta and that you're going to have to use some trig to be able to move from this point. So I'm going to go ahead and pause here, and if you feel like you're able to finish the problem from here, you should try it. Okay? All right, if you need a little extra help, I'm going to go ahead and move down. So everything that I did for setting up the forces is going to be in red, and everything that I do from here on out is going to be in the corresponding color. Okay, so let's focus on the y component, and then let's go ahead and focus on solving for the x component, and then we'll go ahead and see if we can create a system of equations. So I'm going to go ahead and switch to pink, and I'm going to go ahead and solve for the y component. So if I want to solve for the y component, I have to acknowledge that theta, right, is, or sorry, the y component is going to be adjacent to theta. So if I want the trig function, I'm going to say that the cosine of theta is equal to the adjacent over the hypotenuse, right? So the adjacent is fty, and the hypotenuse is ft. So multiplying both sides by the tension force, you should get that the y component times the cosine of theta is going to equal to, oh sorry, the tension force multiplied by the cosine theta is going to equal to the y component. Okay, let's go ahead and switch to green so that we can solve for the x component. So the x component is the opposite side, so we'll use sine. So sine theta is going to equal to ftx over ft. If I go ahead and multiply both sides by the tension force, then I'll have that ft sine theta is equal to ftx. Okay? Now, I have a system of equations, so let's go ahead and write down those system of equations. I'm going to switch to black. So the first equation that I went ahead and solved for was that the y component of tension is going to equal to the gravitational force. So the y component tension is equal to the gravitational force. But I can go ahead and make some substitutions. So I'm going to go ahead and write down that fty is actually ft cosine theta, right? And then fg is going to equal to m times g. My second equation in my system of equations was that mac is equal to the x component of tension. But I now know a little more, and I know that this is going to equal to m. Now the centripetal force is v squared over r, and the tension force in the x component is going to be ft So you need to go ahead and ask yourself, when you look at the system of equations, which variable do these have in common, first off, and which variable would be kind of hard to solve for? So right off the bat, what I'm seeing is that they both have m. I know a lot of you guys were asking me, am I going to have to measure out the mass of our project? And I hope not. The other variable that it has in common is ft. Well, using just a meter stick, I have no idea how you're going to measure ft. So in solving for this system of equations, let's go ahead and make both equations equal to ft, and then we can go ahead and solve from there. So I'm going to go ahead and pause. If you want to do that by yourself, this would be a great time to move off on your own, and I'll give you guys that chance. Okay, so solving from there, what I would do is I would probably just deconstruct the first equation since it's probably the easiest. So divide both sides by cosine theta, and you're going to get ft equals mg divided by cosine theta, right? And so now I can plug that directly in to my second equation, which is right here. Okay, and so I'm going to go ahead and do that. So my equation number 2, is going to be m v squared over r is equal to m times g divided by cosine theta times sine theta. And you know what? In all honesty, something magical just happened. I don't know if you guys noticed that. Actually, two magical things happened. First, mass is on both sides of the party. So you can go ahead and divide both sides by mass, and mass is irrelevant. The other thing that is magical that just happened is that the sine of theta divided by the cosine of theta is actually equal to the tangent of theta. So we can go ahead and simplify that expression from there. So let's go ahead and simplify. So we got v squared over r is equal to g times the tangent of theta. Okay, now I'm going to go ahead and pause. If you know how to solve for period from here, this would be a great opportunity for you to work by yourself. Okay? Okay, so continuing on. So v, right, is equal to the circumference, which is 2 pi r over the period, right? And v squared would be equal to 4 pi squared r squared divided by the period squared. So that's what we're going to go ahead and put in to our equation right here. Okay, so let's go ahead and do that. So we have 4 pi squared r squared divided by the period squared multiplied by 1 over r. I'm just making my life look a little bit easier. That's going to equal to g times the tangent of theta. Okay, we can go ahead and simplify this expression. R is going to cancel at least one of the terms. And so let's go ahead and rewrite our equation. So we're going to have 4 pi squared r divided by the period squared is equal to g times the tangent of theta. Okay, now ultimately we're trying to isolate t because we want to solve for the period. So let's go ahead and grab another color. We're going to go ahead and cross multiply. Okay. Sorry, it's getting a little sloppy. And we're going to go ahead and have our equation below. So we got 4 pi squared r times 1 is then going to equal to t squared times g times the tangent of theta. And now getting that by itself, we're going to divide both sides by g tangent of theta. Hey, things are looking really nice right now. That will cancel, right? And let's move on to our next page. We have 4 pi squared r divided by g tangent of theta is equal to period squared. Well, period squared is not the period, so we're going to need to take the square root of both sides. So let's go ahead and do that. Okay, and you'll go ahead and get the relationship that it's 2 times pi times the square root of r divided by g times the tangent of theta is equal to your period. Let me go ahead and grab my highlighter. Okay, and that would be your answer. Because if you take a look at this equation, r, you could really easily measure. R is going to be in units of meters, right? And theta, you could also really easily measure because that's going to be in degrees. How could you measure theta? Well, there's a couple ways. You could measure if you go back to the picture. So I'll leave this equation right here for just a moment so you can pause. Okay, so let's go back to the top. To measure theta, what you could do is you could measure out, let me go ahead and grab my highlighter. You could measure out the length of your string, right? And then you could also measure out the height right here. And you could solve for the different lengths, and that would give you the theta angle right here, right? So I'll kind of just leave that up to you. I'll remind you guys, right, that if you are going to grab the length of the string, that this triangle, right, you need to be careful about the lengths when you kind of directly go from one part to the other. So like if you get the length of the hypotenuse where I just highlighted, let me go ahead and grab my highlighter again. So where I just highlighted right here, right, you need to make sure that you also take into account that this triangle, right, is going to follow this dimensions right here. So you would need to really pay attention to this little chunk right here not being included in your measurements. So that's the only thing that comes to mind. Do let me know if you guys have any questions. I do want you to turn this lab notebook in regardless of whether you finish or not. Remember that you need to have a full procedure, you need to have a derived equation, and then you have to have a measured period. So this derivation video and this help video that I just created is only really one part of the picture. So hopefully this helps. Do let me know if you guys need anything.